The F-test, decomposing variation and building the ANOVA table. ANOVA decomposes the total variation in the data into two parts. The total sum of squares, SS total, measures overall variation. SS between measures how much the group means vary around the grand mean. This is the signal. SS within measures how much individual observations vary within each group. This is the noise. Here are the formulas. SS between sums the squared deviations of each group mean from the grand mean, weighted by sample size. SS within sums the within-group variances. To get mean squares, we divide each sum of squares by its degrees of freedom. Degrees of freedom between is k-1, where k is the number of groups. Degrees of freedom within is n-k, the total sample size minus the number of groups. Mean square between equals SSB divided by DFB mean square within equals SSW divided by DFW. Finally, the F statistic is the ratio of MSB to MSW. Think of it as signal divided by noise. A large F suggests that group differences are real, not just random variation. Here is the ANOVA table for our pets and stress data. The between row shows SS of 2,387.7 with 2 degrees of freedom and a mean square of 1,193.8. The within row has SS of 3,561.3, 42 degrees of freedom, and a mean square of 84.8. The F statistic is 1,193.8 divided by 84.8, which equals 14.08. The p-value is extremely small, 0.000021. This is highly significant evidence that heart rates differ across the three groups. The F statistic follows an F distribution, which is always right-skewed and starts at 0. Here is the F distribution with 2 and 42 degrees of freedom. The rejection region is in the right tail, beyond the critical value. Our F statistic of 14.08 falls way out in the extreme right tail, far beyond the critical value, confirming the very small p-value. In summary, total variation decomposes into between-group and within-group sums of squares. Mean squares are sums of squares divided by degrees of freedom. The F statistic is the ratio of MSB to MSW, measuring signal relative to noise. And the ANOVA table neatly organizes all these calculations.